Hi, everybody. Today is Tuesday, August 25th. You are at the Kubernetes SIG Testing bi-weekly meeting. I am your host, Aaron Krickenberger, and this meeting is being publicly recorded and will be posted to YouTube later, so you can all watch yourselves adhere to the Kubernetes Code of Conduct by being your very best selves and not being jerks. Uh, on the agenda for today's meeting, we have Jordan Liggett, who's going to give us a deflaking demo or tutorial, a demonstration of how he and others have deflaked many A2E and integration tests over the past couple of weeks. And if we have time after that, I thought I would update everybody on the progress we've made on implementing the Kubernetes CI policy improvements we discussed a couple meetings back. So with that, I'm going to hand off to Jordan.
All right. Let me share my screen if I can. It says I cannot.
I am going to make you a co-host so that you can share your screen. All right, give that another shot.
All right. How is that? Can you see a couple things up there?
Great. Two windows.
All right. I threw a link to these notes in the agenda as well. I will probably clean them up afterwards and post them somewhere less ephemeral than a gist. But if you want to follow along, or if my screen is not working well, that link is there for you. So my goal for today is to sort of help you get into the mindset of deflaking and fixing flakes, and then show you some ways to find things to fix and give you some tools and techniques to make you more effective at fixing flakes and avoiding them in the first place. So I thought I'd start with the mindset. In general, a flake means that we have a problem. And the problem can be in one or more places, but a failing test is not a thing we want. And building that into our mentality as a community will help us a lot. And so thinking about where the problem is, it could be in the thing that's being tested. That's the ideal, right? Like if a test fails, we really want that to be a good signal that we have a thing we need to fix in code that we ship and run. But sometimes there's a problem in the test itself. The test's making bad assumptions or is written in a fragile way. And then the third possibility is that the thing running the test has a problem, so like infrastructure issues. And so as developers, the temptation is to assume that our code is perfect and our tests are perfect, and the problems are always in the infrastructure. And sadly, that has been more or less true at various times, but we've worked really hard over the past month to improve CI infrastructure consistency to make it a better signal when a test fails. So the goal is, in an ever-increasing way, when a test fails, that means there's a problem in the thing being tested or in the test itself, and it really needs to be looked into. So then the next temptation is to assume that flakes are a test-only issue. So if the test is timing out, well, we should just increase the timeout on the test. If a test job is taking too long, we should just increase the runtime of the job. And sometimes that's true, but the mindset is to understand the reason for the failure before you try to compensate for the failure. So some examples, if you're seeing a flake in a test, and if you add a timeout or add a poll or something and the flake goes away, make sure the thing that you are polling for or waiting for is supposed to be an asynchronous thing. That's not always the case. We've discovered times where a test, by polling or waiting, we were actually changing what the test was verifying. Another example is lengthening timeouts. So I have a couple examples here. So this is an example of a test which was depending on garbage collection. And it was running in our E2E tests. And in our E2E tests, we run a lot of things in parallel, and new API types show up and disappear. And when new API types show up and disappear, that can actually garbage collection into a back-off state briefly, where it says, well, I need to clean up this thing, but this thing doesn't seem to exist anymore. I'm going to kind of wait for 30 seconds and resync. And so it's not unexpected that garbage collection would sometimes take 30 seconds longer than other times in an E2E test. And so a test that's depending on garbage collection should, in our parallel E2E tests, should tolerate a delay like that. So in this case, adding a timeout was appropriate. In another example, an operation that we expected to be very, very fast was actually very, very slow. And so by digging into the logs, we were seeing that a particular operation that we expected to take like on the order of a second was taking 15 to 20 seconds. And so if we had just blindly added a 1-minute timeout toleration to that E2E test, we would have missed that we had a pretty severe performance bug. And so the fix, let me see if I can find the fix for that. I think this was where he fixed it. Yeah, so by fixing the bug, he reduced the runtime of this method from sometimes takes 15 seconds to consistently takes about 2 seconds. So adding timeouts in the appropriate places are fine, but we want to make sure we understand the root cause before we do that. And then the last thing I'll call out is just make sure that the changes you make to the test are still testing what you expect. So this was one we discovered recently where there was a flaky test in the plugin watcher. And by changing the test, by initializing things in a different order, we could make the test run consistently. But by initializing things in a different order, we actually weren't exercising reality. Like in reality, the kubelet starts and it could start before or after or during plugins. And so our test shouldn't care what order we start things in. It should be resilient to any order. And so Michelle did a really good job of noticing that the initial fix was actually breaking what we were supposed to be testing. And we ended up fixing a real bug. And so this turned into a bug fix instead of a flake fix. All right. So now that we have that mindset, how do you find flakes to fix? You would think this would be easy as much as we complain about flakes, but sometimes it's actually kind of hard to find things that are actually important to fix. And so here are some good places to start. Issues that people have already reported. We have a label, kind flake. So looking for issues that have already been reported, and that can help you see if someone's already working on this or how much this is getting mentioned. If people are saying, yep, I saw this, I saw this, I saw this. That's one place to look. And you can filter these by SIG label to see flakes relevant to your SIG, if that's where you want to start. Another place to look is this report, which reports on our flakiest jobs and the flakiest tests inside those jobs. This actually looks better than it has in a long time, which is excellent. So used to, you would open these up and there would be like 5 or 6 really bad flakes in each job. So that is less the case now, which is excellent. But that's one place to look. Of course, we all have encountered flakes in our own pull requests. So that is also a place to start. If you see a failure, take a look at what it was and see if there's an open issue for that flake before you retest. And then these two resources, the test grid and the triage board, are good ways to find flakes in our different jobs. So here's our GCE container D test grid, and you can make this super small, and then you can see which tests have been failing. It looks like we kind of have a variety. There's not like one test that's repeatedly failing, except this one, which we already have an issue for. But this can be a good way to sort of identify, once you zoom out and see like several weeks worth or a week's worth of runs, if you see one test failing repeatedly, that could be a good place to start. And you can also filter this down to anything in the test name, but SIG is a good thing to filter on. So that if you're looking for things specific to your SIG, that's a good way to find them. And then lastly is the triage board. I love this. This just got rewritten in Go. It's much faster now. And this is one of the most powerful tools that I use. It lets you filter by SIG. Now these are the SIG titles associated with the tests, so that doesn't always show you exactly what you want, but it can be a good starting place. But then it also lets you filter on failure text or the job name or the test name or any combination of those things, and then exclude specific things. So if I wanted to find something related to that kube control flake about standard in, I can put in failure text, find how often it's happening, and then jump down and see all the specific jobs where it's failing, and then even links to specific instances. So that is a good place to start. As an example, reset that. As an example, I went through some of the SIG auth attributed failures and found some really noisy tests that had been marked flaky and just kind of ignored for a long time, and actually cleaned those up. So the SIG auth filter signal is much clearer now, and we'll be working on getting these cleaned up as well. All right, so what are good things to put in a flake report? Let me pull this over, and we can talk through some of the helpful things to put in. If something is failing in multiple jobs, we see this especially in our end-to-end tests where we have different variants of them, different container runtimes, different network setups. If something's failing in multiple jobs, that's helpful to know. If we're seeing something fail in only one variant, that's also helpful to know because it might be something specific to that variant. If there's more than one test that is having the same failure text, that's helpful. The triage board is great for figuring this out. And then specific links to the test grid queries, the reason for the failure, so that when you search GitHub for like some random text in the failure, you find it. Links to the triage board, and then specific failed examples. All of these are super helpful for helping someone who wants to dive into fixing this get context right away. And most of this is in the flake template, the flake issue template. But I thought maybe a specific example of like what good things to put in there would be helpful. All right, great. So now we've found a test that's flaking that we want to fix. I thought I would go briefly through ways to reproduce flakes in each different kind of test. So one thing I really like about unit tests is that you can reproduce them locally. So I am in my Kubernetes folder, and there is an open issue about a flake for this unit test. And so if I just run that test, sadly, it passes. Now you notice it says that was cached. You have to watch out for the Go cache. It will cache test results. And so you can bypass that by telling it some uncacheable argument, like how many times you want it to run. So that is no longer a cached result, but it's still passed. So that means we've definitely got a flake. Like it's passing for me. So what's the next thing we can try to reproduce this flake? The race detector, and I have a link to the discussion of that, will actually rewrite the code when it compiles it to sort of put in delays or detect weird interactions between asynchronous operations. So sometimes running with race mode will reproduce a flake, but it turns out that passed as well. So we have to go deeper. My favorite tool this year is the stress tool. And so I linked to that. I already have it installed. But what that lets you do is build a binary for the test. So go test. I want to build it with race detection enabled. And instead of telling it what test I want to run, I'm going to give it the -c argument. And that is telling it to compile the test. And that is going to create this binary in my current directory. So now I have a binary which I can run standalone, and I can give it this same argument. So when you run standalone, you have to give it the test run argument. I can run it standalone, and it still passes. But now if I stress it, this is going to run a bunch of instances in parallel over and over and over and over. So in about 5 seconds, it ran almost 300 instances of that test. And as you can see, it's flaking immediately. Like the flake that we were observing reproduces almost instantly. That's super, super useful. And so sitting there like running 300 times. And so now we have a reproducer. Now we can start to dig in and try to figure out where the problem is. So that's what I love doing for unit tests. Integration tests, you can actually do really similar things. Most of our integration tests expect an etcd instance to be started. So you can do that pretty simply by just starting etcd in another tab. And then you can run the integration tests using the same method, either directly with GoTest, or you can build them into a binary and stress them. The question was, where's the stress binary? I linked to it right there, and you can install it with that go get command. So for just simple flakes where we're seeing an integration test failure, that same approach works pretty well. One interesting issue that I ran into was a deadlock or a timeout that would fail the entire package on an integration test. And when that happens, it barfs out about 10 trillion Go routines, and you have no idea which test even failed. The question was why it can be compiled into a binary. So it's actually compiling the tests for that package into a binary. And the reason is so that we can invoke that with stress. So it's not recompiling the tests every time. We build the tests once, and then we invoke them a bunch of times in parallel. So this is something that we've seen on a few of our packages. We don't see it super often, but I wanted to talk about how you could track that down. So this was the SIG scheduling integration test was deadlocking and timing out. And so the way that we tracked this down, when we just stressed the whole package like this, we could see it was completing 10 runs of the package, then it was completing 9 runs of the package at a time, then 8 runs at a time, then 7, then 5. Like gradually, the test runners, I think it defaults to 8 or 10 in parallel. Gradually, the test runners were getting hung up on some deadlock, and then fewer and fewer were completing at a time. And then finally, after 2 minutes, we got a timeout. And so the way that I broke this down was to stress individual tests. So first, I would just run one test in the package, and I would see how long does this test take normally. And so if it took, a tenth of a second normally, then I would stress that one test, and I would give it generously like 100 times as long as it normally takes to complete. And this way, I didn't have to wait for 2 minutes for the timeout to happen. If it was going to time out, it would time out after 10 seconds. So I'm running one test, giving it a 10-second timeout when normally it takes a tenth of a second or whatever. You have to figure that out per test. And then I stress it in parallel. And basically, I let these run for 20 or 30 seconds. And once it was happy for 20 or 30 seconds, I said, well, that's probably not the culprit. And so I just went one by one by one by one, and this was the culprit. This one took a tenth of a second on average. When I stressed it with a timeout of 10 seconds, after 10 seconds, immediately I was getting timeout flakes. And so that gave us a particular test to look at. Once we had a particular test to look at, our job is much smaller. We're just trying to break the problem down and find where the particular problem is. So looking at that test, it was timing out on this wait. So then we start adding debug logging to the places where we could return early or see the thing that's going to unblock this. And once we did that, the issue was pretty quick to resolve. It turns out we weren't waiting for all of our caches to be synced before we were starting the test. And so the event we were waiting for in the test happened before we kicked off the wait. All right, so now everybody's favorite topic, EDE tests. Okay, so remember we said the problem in a flake could be the thing that's being tested, right? Well, the bad news is for an EDE test, the thing being tested is everything, pretty much. So on the one hand, that's good because we do actually want to make sure our system works when you run the whole thing. We've all seen like the comic of like unit tests pass, integration tests fail, with like 2 drawers that each open individually, but you can't open them at the same time or whatever. But the bad thing is an EDE test can fail because of something completely unrelated. So an example we ran into today, a Gluster volume subpath test. Like you look at the test title and you're like, oh man, we must have a Gluster problem or a subpath problem or a volume problem. But nope, the problem is that the namespace the test was using got deleted by something. And so like the setup for the test failed because the namespace was being deleted. And so just be aware that you can't just look at the title of the test for an EDE test. You actually have to dig into what the problem is. And so the takeaway is prefer unit and integration tests if those are sufficient to test the thing you're looking at. And then, yeah, don't assume the title of the EDE test identifies the problem. So the steps that I follow for deflaking an EDE test, first step is just gathering information, right? So this link is going to go stale because we reap our artifacts from EDE runs, but hopefully you get the idea. There's a lot of things we capture from EDE runs. So if you are used to seeing a screen like this with some random failure, and you click on this, and you think, well, now what? Like, this is clearly not enough information to figure out the problem. This artifacts tab is your friend. Under here, we have the build log, which is all of the output from the test when it was running. But then under artifacts, we capture tons and tons and tons of logs. So for the control plane, we capture logs like the API server audit, which will tell you in detail every request that was made and who made it and what order it was made in. And don't forget that there's archived, rotated versions of them. These are big, but if you need to know what order things happened in, they're very useful. The API server log, the controller manager, and the scheduler. Those are the main logs that you normally care about on the control plane. And then for each node, and most of our EDE tests set up 3 node clusters, we capture the container runtime log, so that's either Docker log or containerd. We capture kubeproxy, and we capture kubelet. Those are the main things you might care about for most EDE issues. So once you have those things gathered, the next step is to filter and correlate that information. So if your first step is to kind of pick likely candidates, like the things you know that interact around this issue. It might be the test is doing something, so you care about the test log and the API server log, and then the controller manager is going to do something and the kubelet's going to do something. That's a pretty typical set, maybe the scheduler, but that's a pretty typical set of interactions. And so you can pick the logs for those components and then filter to things that happened around that time or things that happened around the objects or the namespaces in the test. Depending on what it is, if you're seeing an issue where a controller is taking too long to do something, maybe you just want to filter to things that happen around that time, because maybe it was busy with some other namespace. Like it was spending time doing something else, hanging on some other namespace, which is why it didn't get to your test. So if you only look at your namespace, you'll miss maybe the root cause. If you're trying to figure out how a particular object got into a particular state, a pod got into a particular state or something, then filtering just to that pod or that namespace is probably reasonable. So you can filter the logs for the relevant things. I like to keep timestamps at the beginning of the logs, and then right after the timestamp, put something that identifies the component, and then merge all the files into one file and sort by time. And so you end up with something like this. Let me see if I can find, there we go. So this was when we were trying to debug a garbage collection issue. So you see the timestamp. So this is the API log, kube controller manager. So this is the controller's perspective, the API's perspective. I thought I put kubelet in here. Maybe it was just those two. Oh yeah, and then, so this was the output from the E2E. So this was the test code that's running. So when the test started looking for the thing to go away, maybe that was it. But you get the idea. You take the logs from the relevant components, you filter it down to sort of the time you're interested in or the objects you're interested in, and then you collate them. So you can get a complete picture of this distributed system and where things went wrong. Another thing that can be confusing, we have a lot of nested systems. So we invoke things which invoke things which invoke things, and sometimes the logs that you see surfaced actually come from like a component 3 levels deep. So this is an example of a bug in runC, which was actually an old version of runC configured on this particular job. And so the clue to this was the line numbers of the message. So in the error message, we see process Linux line 449 and then stuff happening. And if we look at the version of process Linux that we have in Kubernetes, that line number doesn't match where that message comes from. And so tracking that line number down actually pointed at the runC component. And then when we started searching runC for issues around C group files, we found that they had fixed a bug where they were retrying an interrupt. And so we picked up a new version of runC and resolved the issue. So don't make any assumptions about like where the problem originated just because of which log it showed up in. So matching up line numbers can be super helpful. And then finally, if you are trying to figure out like which branch is being taken or what timing issue is happening, and we don't have log messages, like feel free to add them. Adding debug logging to track down a flake is totally acceptable. So I'd like to do an example of that. All right, so now you've reproduced the flake, you've found like maybe sort of the area where it's happening. What are the types of things you can do to look for and to sort of force the flake to happen? So the first thing, does the test assume that something that's happening asynchronously is happening synchronously? So is the test going to do something and then immediately check a condition when really the thing that's going to make that condition pass might not run right away? And then there are ways to simulate this. So if the test is kicking off a Go routine, or the component that's being tested is kicking off a Go routine, put a sleep at the top of the Go routine. And that will simulate the Go routine taking a while to start. And I say a second, but it could be 5 seconds or whatever. Try that and see if that makes the flake happen reproducibly. These are all the types of places where we normally do asynchronous things. So if you have a watch event handler, see if I can. So if you have an event handler like this, to simulate watch events being delivered slowly, do something like that. And that will make your handler act as though it's getting watch events slowly, which can happen under load. do things like that to see if that makes the flake reproducible. And then a normal pattern is to observe watch events and then queue up work to do. And so try doing the same thing in the worker. If you put it at the beginning of the worker, then that simulates a worker that's bogged down and is going to react slowly to work. And if you put it at the end of the worker, that simulates a worker that does work, but then gets distracted with other things before coming back to pick up new work. So you can try sort of each of these in turn and see if you can trigger the flake. This is sort of similar, but sometimes a test will do work and assume that it can complete its work, but there's a background process running that's going to do conflicting stuff. So this was a good example where the test was doing some setup. It was creating a service object and then creating an endpoints object. And most of the time that was fine, but we actually have a controller that when you create a service object, will create endpoints objects for you in the background. And so if the test setup lost the race, the test would get an already exists error when it was trying to set up its endpoints. And we could trigger that by putting a sleep in between the steps of the test. So this is just ways to force timing errors, force the test to win a race or force the test to lose a race by making individual steps artificially long. A couple rules of thumb. Tests that assume things are going to be fast. Something that takes like a second or less locally could take a few seconds in CI environments for a couple of reasons. CI environments normally have more resource constraints than like a local powerful dev machine. And often we run multiple tests in parallel. So maybe it happens really fast when you run just your test, but if you run 10 or 15 or 20 tests in parallel, things slow down a little bit. So unless your test is specifically a performance or timing test, don't put super tight tolerances. Wait.forever test timeout is set to 30 seconds. That's a reasonable thing to use for, quote unquote, things that should not take very long. That's useful when we don't want a test to hang for 10 minutes before failing. We want it to actually fail quickly. But we don't care for the purposes of this test if it takes 1 second or 5 seconds or 10 seconds. This is not a performance test, it's a functional test. And so we just want to wait a while before deciding that the functional test failed. Another thing we see a lot of is assuming deterministic output. So these are just your friendly reminders that map iteration in Go is non-deterministic. And so if there is something being, a list being compiled or a set of steps being done by iterating over a map, those are going to happen in non-deterministic order. So either sort and compare or tolerate any order. So there's a link to an example of that. This was a fun one that we found. Sometimes we have things that will do random allocation. So if you create a service, it will randomly allocate you a cluster IP. We also can request a specific IP. And so we had a test that was creating one service randomly and then creating another service with a specific IP. And 1 out of every 256 runs, the randomly allocated IP would be the same as the static IP, which we later requested, and we'd get a conflict. So just be aware if you're mixing those. And in this case, there was actually a bug that we could fix to improve things for everyone. So that kind of goes back to where should we make the fix? Is it a test-only issue, or is it a real bug we should fix? So in this case, it was a real bug we could fix. And then the last one I was going to call out, if you're using a fake client and you have like an informer watcher on it, it can do a read list and a rewatch at any point. And so if you're making fake client calls and then expecting like exact actions to be output, those can get interleaved spuriously with the informer in the background. So it's better to look for the specific things you want it to happen instead of just asserting exact matches. That is everything I could think of in 35 minutes. Yeah.
Any questions for Jordan? How long would you say it takes to sort of run one of these down?
Once you know the tools and kind of get a workflow to where you can do the gathering and the filtering and the correlating, that usually takes, I mean, just that bit. Once you get it down, it takes 5 minutes. Like it takes a while to get that workflow down, but once you have something correlated, it really varies. Sometimes the issue will jump out at you immediately. Sometimes, like you saw, the one where we had to add more debug logging because we didn't have enough information about the timing stuff. There is no usual. It could be 5 minutes. It could be a month.
I totally understand it's kind of a long tail for some of these things, but just sort of a gut check. Like I feel like I've seen you and some other folks go through an impressive number of these lately. So it does feel like there's a bit of a rhythm, at least as far as uncovering some of the lower hanging fruit in unit and integration tests.
Yeah, the unit and integration tests are way, way easier and faster to figure out just because of the rapid, make a change, reproduce, make a change, reproduce, make a change, reproduce. So those you can actually normally resolve, or at least root cause within a couple hours. Sometimes once you find the root cause, the root cause is this test is fundamentally wrong and we need to rewrite it. And so that can be tricky. But root causing unit and integration issues you can normally do within a day and often within a couple hours.
Okay. So if folks are like looking at a test and they're trying to figure out like what is actually being tested, is the test right or is the test incorrect? What advice would you give folks for like trying to find the appropriate expertise there?
Yeah, I mean, the more realistic the setup of the test is, the better. So if you can use the same constructors to set up the controller or the component that are really being used when we run the thing in production, that's nice. Sometimes we'll see issues where the setup code was faulty and we were sort of hacking together fake clients and artificially running Go routines and waiting for cache syncs and informers in totally different orders than happen when you run the component for real. And so the more you can use the normal constructors, the better. Thinking about like behavioral testing, like we're gonna trigger some input either by calling a Go function directly or by creating some API object and waiting for the component to observe that. We're going to trigger some input, and then we have some expectation of behavior. The more you can limit the test just to the inputs and the expected behavior, the better. Instead of sort of this extremely fragile, like I expect this call to be made, then this call to be made, then this call to be made, and it must happen in this order, and it must happen with this timing. And like for a functional test, that's probably not what we care about. Like, we want an invariant of I create a thing, and then this happens to that thing. And so the more you can scope the test to just those things, the better.
Okay. Since you mentioned integration tests earlier, just one FYI, the part of the reason that the flake query that you linked looked way better than it has in a while is because integration tests don't show up on that right now. It has to do with some of the crowd jobs use one mechanism versus another mechanism to specify the repo they claim. And that means that some of the data that's consumed by our flake queries doesn't land for those. So for integration tests especially, the triage tool is the better place to go looking for what are the integration tests that are failing most often right now, which may be a hint or clue into like what are the flakiest tests that we should look at addressing. We do
Yeah,
have
I will point out too that that the triage board and test grid actually, for some jobs, do not differentiate which branch, and so always, like if you're looking at failures that you found via the triage board or via test grid, always make sure that the PR that flake, especially for pull request flakes, make sure that the flake was actually running on a pull request against the master branch. You will drive yourself crazy trying to track down flakes that were actually already fixed and don't exist anymore in the development branch.
Yep, that is a super valid point. Any other questions for Jordan or comments?
Thank you.
Yeah, all right. Thanks so much for your time, Jordan. Really appreciated that. So with the time we have remaining, I just kind of wanted to give folks a brief off-the-cuff update on where we're at with the CI policy stuff that we, Jordan and Ben and I sort of raised a couple weeks back. So I will share my screen for this. Maybe not all of this is cleanly documented in LinkedIn places. I will work on following up and landing this stuff. But I've been using an umbrella issue called Kubernetes CI policy to sort of find my way to all of the appropriate work streams. Lori Apple's also put together a CI policy improvements project board, which is another way of sort of keeping track of what works in progress and what are we monitoring. I personally haven't had the time to go through and scrub everything. So like I said, this will be a little bit off the cuff. The thing we decided that was most important first was to set, make sure that all of the critical jobs, all the release blocking and merge blocking jobs were guaranteed pod quality of service, which meant they had to declare resource requests and matching resource limits for CPU and memory. To the best of my knowledge, we've basically gotten that done. So there's a test in place that will prevent you from adding any new release blocking jobs unless they have those limits set. I created a tool to generate a CSV, which can then be imported into Google Sheets. And I did some conditional formatting, filtering here. But what you see is everything on here is in a dashboard that has the word blocking on it. And I've specifically manually excluded like the rel-eng blocking dashboard and a few other things. This should cover all the critical jobs. The yellow jobs are jobs that have not yet migrated out of the google.com owned build cluster. The green jobs are those that have, and I have a column specifically for QoS guaranteed true. And pretty much everything is either green or yellow. If I get rid of that dashboard filter, see if I can remember how to do this. So this is all 1,700 and something jobs that are defined to run via Prowl. And you can see a lot of them are red because they don't declare any resource limits. This is part of why step one was to define the resource limits, but step two was to take all of those green or yellow jobs and move them to their own cluster. Because right now, if they stay in the google.com cluster, they're still competing against all of these jobs that aren't declaring the resources. But TLDR, we declared resources for everything. Great job, everybody. One of the ways we were thinking about declaring victory for this was we had discussed how jobs that failed to schedule due in the bad times around July 9th, we had a lot of jobs end up in error state. And this usually seemed to happen because jobs were unable to successfully clone repo, or they were unable to successfully schedule on a cluster due to lack of resources. And so we figured if we got resources set up correctly, then we would have fewer jobs end up in error state. And you can see that over time, I'm looking up here at the orange, these are all the pre-submit jobs that are scheduled. And like they both kind of go down at roughly the same rate. But around about the time that we decided we're doing this and we're implementing, we're declaring resources, the number of jobs that have ended up in error state is not gone directly to zero, but it's significantly flatter and less correlated to PR traffic than before. So I feel like we can use this to say, yes, we have made a difference. This step has had an impact. And I was going to go ahead and declare this closed unless anybody had any objections.
Well, there's still a few items open. So I was also out last week because many of us were in KubeCon or moving, was my case. I think Rob and Dan might have the best sense of what's going on with the remaining items related to this. Maybe one of them wants to speak up?
I think we can call that closed. That issue that Aaron wants closed, I think we can say it's closed.
Sorry, I couldn't quite catch that, Rob.
Yeah, me neither.
Yeah, sorry about that, guys. Yeah, you know, I agree with Aaron that we can call this issue closed.
Okay.
18530, yeah.
So what about the items that are still in the monitoring column? So are they done or?
I will go sweep through those.
Okay.
Yeah, I can help with that if you want to.
So the next item was about migrating all release blocking jobs. These are all the CI jobs that run in post-submit or periodically. Status on that as of 17 days ago, I don't think this has changed. These are the jobs that have yet to migrate over to the cluster. Some of them are related to building Kubernetes, and they involve pushing it to Google Cloud Bucket that only Google.com clusters have access to. There's an open issue where I'm working with the release engineering team to try and migrate to a different bucket that the community-owned infrastructure can write to, but that there's no progress being made on that until 119 is out the door. There's also the Bazel tests job, which probably can be moved over, but I didn't want to change the behavior of how Bazel runs its unit tests while Jordan was deflaking all of the unit tests. For slightly more context, many of the Bazel jobs that run against Kubernetes today use what's called remote build execution. It's an alpha feature that Google Cloud offered for a little while, but I'm not sure is publicly available anymore, where Bazel would do some gathering of resources and whatnot locally, but then ship them all off to some remote execution environment somewhere. And that's where all of the running of tests or building of Kubernetes would actually happen. In order to migrate these jobs to community infrastructure, we need to use what's generally available, which would be running Bazel directly on the nodes in question instead of farming them out to some mysterious place. So we can move on that once we sort of feel like Jordan's fought off all of the unit test flakes that we can. That is, as far as I know, the story with these. Merge blocking jobs. So there are a whole bunch of issues related to migrating merge blocking jobs. Just click through to the one for verify, for an example. Most of these have been taken by people, as far as I know. I tried to describe what to do, how to do it, and then different dashboards or tools to look at and questions to ask yourself as you look at these dashboards to see if the job has become healthier or not. I haven't swept through to see how people feel about all these, but in aggregate, I'm starting to have concerns that we are bumping into quota issues. So I will link to this comment here. Pictured here is a graph of the number of VMs in our community-owned build cluster. We auto-scale as we have more jobs that are declaring their resource requests. And I can sort of see that traffic has gone down quite a bit, but even at this low reduced level of traffic, we were peaking up at around 60 VMs, and we were starting to bump into related quotas. So I've been trying to bump up those quotas and not having much success. So in the interim, there are a number of suggestions I've put here on ways we could work around this. I would really love to just do the simple thing and raise the quotas and forget about this. But in the event that we can't, I have concerns that when we sort of open the floodgates and allow PR traffic for V120 into Kubernetes, we might start to bump into these quota issues again. So I feel like we need to take mitigating steps. The simplest one, which Zhifeng suggested here, was moving jobs out of the community visible cluster back into the google.com cluster. I kind of didn't want to do that just right now while we do have the capacity, so that we can get more data about how these jobs are behaving. Because if we move them back, we lose visibility into what the jobs are doing and why they're failing. The cluster that lives in google.com was stood up many years ago and uses different monitoring, different metrics. So the dashboards that some of you have been using to keep track of how the jobs are doing, we don't have equivalents to that even as Googlers. So it is more difficult for us to troubleshoot what's going on. So as an example, one of the things we tried to do to maybe mitigate these quota issues was, instead of having more smaller VMs, what if we had fewer larger VMs? Larger VMs get more I/O. So maybe that would mitigate the effect of stacking more jobs onto larger VMs. So this is one of the dashboards you can see if you're a member of Fates Infra Proud Viewers. This tries to show resource usage in aggregate for the community-owned build cluster. We migrated from the larger, more small nodes node pool to a fewer larger nodes node pool kind of over the weekend, and it became pretty apparent pretty quickly that the verify and integration jobs were not doing well. We can sort of correlate that to these I/O-related graphs that show throttled disk operations. We can see that we started having a lot of throttled read operations when we were running on those fewer, smaller nodes. So we've migrated back. Hooray. I'm still sort of keeping an eye on our node pool size because we're still kind of, we can't get too far over 60 VMs at our current limit. And I'm trying to correlate what's causing these things to spike up. So we've got more metrics available for like the pods and jobs that are running on the various nodes. This graph, for example, shows you that like more pre-submits, sorry, this should be highlighting when I'm moving over, but a lot of pre-submits started spiking around this time, which correlates pretty closely to the number of VMs spiking as well. So why were there so many pre-submits running? Like they're down here, I can sort of see the pre-submits aggregated by which pull request was triggering those pre-submits. So here it looks like pull request 94115 probably like had a bunch of commits pushed to it, or maybe somebody was spamming retest or test all a bunch. And so in a 1 hour interval, about 34 pre-submits were all scheduled. So I just sort of feel like if I look at I lost the graph. If I look at the graph that sort of showed pre-submit traffic going down over time, I feel like even at this reduced level of traffic, we are already scaling our VMs and hitting quota. So we may need to consider mitigating that. But otherwise, I'm hoping these graphs have been more useful to the CI Signal team and everybody who's joined the Proud Viewers group to sort of better understand what's going on. I will stop talking.
Do you know what your next step might be for resolving or coming up with a mitigation for this issue? Like how would you go about it?
So like I said, I tried to describe a bunch of potential workarounds. in the linked comment that's linked off of what's stopping merge blocking jobs from moving forward. And my bandwidth has been limited to move on these or to further spell them out so that other people might move on them. The quickest, lowest phi solution that people can do is to move jobs back to google.com. But that's going to move them back to that sea of red jobs. And so we may find that we still don't have the greatest situation. The longest term solution would be to get our quota raised, which I am attempting to escalate both internally and externally. And if anybody here has suggestions or ideas on how to do that, I would appreciate that help. An even longer term solution would be to re-architect how we do our build cluster. Today, the build cluster is constrained by a quota of external IP addresses. If we redid our cluster so that it didn't require external IP addresses, we wouldn't be blocked by that quota anymore. However, that introduces the complication of how do we handle inbound and outbound traffic. This is something we haven't had to deal with yet, so there would be new engineering effort that we haven't had to do historically. And thus far, I've been trying to keep us as apples to apples as possible as we migrate jobs from inside of Google to outside of Google. That puts us at time. I appreciate everybody listening to me talk for so long. Hopefully that was useful. Lori's asking great questions, and I hope to do my best to answer them on issues, scrub through the board, and take more questions in Slack if people have them. As I said, my bandwidth has been a little bit limited and will continue to be limited on executing on this a lot. So anything you folks can do to kind of like update the individual issues that you have taken on to sort of status check how good or bad things look would be helpful and appreciated.
And I guess the metrics topic will wait until we resolve this immediate issue. Is that the plan? Like punting that for now, given your time constraints plus this other concern?
We'll see. I gotta take it offline.
Okay. Just for like what people can work on.
Yeah.
Seems like maybe now that's not the best time for the metrics topic, but yeah, you'll figure it out.
Yeah, I think sort of trying to continue to figure out how we can identify and measure the pain that we are experiencing would be more helpful. I still feel like we're doing an awful lot of maybe it's this or maybe it's that back and forth, which can make it scary to change things. I would like to figure out how we can change things with confidence rather than doing like big, slow, very cautious moves. But that's just a stylistic choice. Okay, thank you everybody for your time. And with that, I will stop recording and see you all in 2 weeks. Happy Tuesday.